The delicate balance of the entire solar system exists in a gravitational dance between planets. Swap the orbits of two of them and you could end up wreaking all kinds of havoc. What would happen to a rocky, red planet stuck between two gas giants? How would Earth react to a gigantic new neighbor? And why would a big shift in gravity trigger an asteroid apocalypse? Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. The Sun and Jupiter are the two largest objects in our solar system. The gravitational forces of these behemoths influence each other's movements. And they have a big impact on the movements of all the other planets, moons, and asteroids in our cosmic neighborhood. On the inner side of this belt is the fourth planet from the Sun and our neighbor, Mars. The red planet is located a mere 78 million kilometers, 49 million miles, from Earth. That means it's 8 times closer to us than Jupiter is. Jupiter is the fifth planet from the Sun, located at a distance of about 778 million kilometers, 484 million miles. And it's the gas giant's tremendous force of gravity that could be responsible for the asteroid belt separating the inner and outer regions of the solar system. So if these two planets suddenly swapped orbits, would the millions of rocky objects in the asteroid belt come flying right at us? Let's start by checking out how Mars would fare in this orbital switcheroo. It would now be jammed between the gas giants, Jupiter and Saturn. This would put the red planet in the uncomfortable position of having the two biggest planets in the solar system on either side of it. And it would be uncomfortable because of those gas giants' gravitational pull. But the pull would be uneven. And Mars would suffer a similar fate to that of one of Jupiter's moons, Io. Like Io, Mars would experience a stronger attraction on the side facing Jupiter compared to the side facing away. This would stretch and compress the rocky planet. Mars would start to heat up from the inside. That's the reason Io is plagued by more active volcanic eruptions than anywhere else in the solar system. Place Mars in a similar game of tug-of-war, and the gravitational forces could be strong enough to reactivate a few of its own ancient volcanoes. You could end up seeing lava erupting out of Olympus Mons, the biggest volcano in the solar system. Hopping back over to our side of the asteroid belt, things would be getting interesting here on Earth. The first big change you'd notice would be the night sky being a little different. Jupiter would go from appearing as a distant bright star to being about 20% as large as the moon. Looking up on a clear night, you could see its colorful bands and spots. But not everything would be swirly and pretty. In its new real estate right next door, Jupiter's gravitational impact on Earth would be about 64 times stronger than it is now. Jupiter already impacts us from a distance. Every 405,000 years, its pull, along with Venus, is responsible for droughts and intense rain. With it being this close, the effect would be more extreme. And the consequences deadly. Caught between the Sun and Jupiter, our planet would experience cataclysmic problems with tidal bulging. So what you once knew as a lovely, habitable home would transition into a volcanic hell. That wouldn't be the only hell unleashed. With Jupiter suddenly on the opposite side of the asteroid belt, all those millions of rocks would be pulled in new directions toward it. And that would set more than a few on a crash course with Earth. The objects in the asteroid belt range in size. On the massive side, there's the dwarf planet Ceres. It's about 25% the size of our moon. Of the asteroids, Vesta is an unwieldy 530 kilometers, 329 miles across. An asteroid wouldn't even need to be anywhere near that large to hit Earth and trigger the apocalypse. A collision with one as small as 1 kilometer, 0.6 miles, could be the end for us. If an asteroid about 10 kilometers, 6 miles, across crashed into our planet, it would result in the sun being blocked out for a year or more. And without sunlight, we'd experience what's known as impact winter. Temperatures would drop and photosynthesis would stop. This would all lead to the mass extinction of plant, animal, and human life. Thanks, Jupiter. But at least the largest asteroid didn't collide with Earth. Yet, Jupiter can be seen even without switching orbits with Mars. In June especially, the gas giant is visible south to southwest of the night sky, with Saturn visible from dusk to dawn all month due to it being directly opposite the Sun in the sky. If Jupiter switched places with Mars, Jupiter will be twice as far from Earth as Venus at about 78 million kilometers, making it the second most easily viewed planet in the sky, only surpassed by Venus' luminosity. Earth's orbit will degenerate into a very large aphelion, with a very close approach to Jupiter at its axis. The Moon will be released from its 1:1 tidal lock with Earth and may move further away during the aphelion phase of its orbit around Earth, resulting in unpredictable tidal motions on Earth, and on a positive, we will be able to view the dark side of the Moon. Furthermore, the Moon's core temperature will increase due to tidal friction between Earth and Jupiter's gravitational pull. But that will only be the tip of the iceberg of the catastrophic events that follow Jupiter's switch with Mars. You see, Jupiter drags, along with its 67 moons, around 6,000 asteroids known as Trojans along its orbit. These are remnants from the formation of the solar system that liberate along Jupiter's Lagrangian point. Jupiter is also fundamental in stabilizing the orbit of the asteroid belt and prevents the asteroids from pulling themselves into planetoids or planets or accreting into the Sun. If Jupiter's orbit switched with that of Mars, Earth will be placed in the center of an asteroid superhighway. There are about 1.7 million known asteroids and Trojans with a diameter of more than 1 kilometer and about 200 asteroids with a mean diameter of 600 kilometers wide. These would cause an extinction-level event if they ever collided with Earth. So, no, Jupiter, as you were. I'm going out on a limb a bit here, because there are so many variables I'll have certainly forgotten one. But I'm going to say yes. I considered a number of parameters: temperature, radiation, stability of orbit, weather, increase in asteroid impact, gravitational heating. Let's take them in order. Temperature: it's going to get colder here, but I don't think cold enough to kill us. We'll be slightly closer to the Sun during part of our orbit, which will warm us up, but the distance reduction is trivial. The problem is the shadow. Suppose we orbit at the same distance Europa currently orbits Jupiter. Our period around Jupiter is 85 hours, of which we could spend as much as maybe 15 hours in the shadow of Jupiter. That's something like a 20% reduction in insolation, which is going to make things a bit chillier. Normally, I think it might be enough to freeze us solid, but I've got some good news later on which will help us a bit in that department. Radiation going near Jupiter is dumb. Really dumb. Jupiter spits out an obscene amount of radiation, enough to fry our innards like an egg in relatively short order. But in your scenario, we've got a secret weapon, the magnetosphere. The same shield that protects us from the Sun's radiation should protect us from the worst of Jupiter's as well. But there's more energy going into the atmosphere, which means a bit more heat when it's all over. That's actually good news. There's also probably a bit more cancer, which is not so good. But I don't think the radiation will be sufficient to kill us. Stability of orbit. This one is really tough. If we are orbiting far away from Jupiter, it's possible that the Sun's considerable pull on us at apoapsis is enough to perturb our orbit into an elliptical one, which eventually becomes unstable. Planets as close to the Sun as we are currently don't have big moons. Our moon is by far the largest. But on the other hand, Jupiter is really massive, so it should be able to lock us in. If we're close, this is more likely to be true, but we encounter another problem: tidal locking. The major moons of Jupiter are tidally locked, which means one face points toward Jupiter at all times. Our moon is tidally locked to Earth for the same reason, which is that the moon is quite close to a much more massive planet. Europa is a little less than twice as far from Jupiter as the moon is from the Earth, which suggests that if Earth orbited Jupiter, we'd be tidally locked to the giant planet. But this introduces all sorts of weird scenarios for the amount of light that the Earth would receive from the sun, which affects the